Okay guys, today I'm going to teach you about tornadoes. Okay, so tornadoes are a pretty complex phenomenon that happens, actually particularly in the United States. There's an old saying that says, tornadoes hate America. Okay, there's some truth to this because the continental United States has the perfect conditions to draw up this very unusual weather phenomenon. So in order to have a tornado, you need warm, moist air, cold, dry air, something called wind shear. You need a humid ground. You need strong condensation updraft. And then that's going to create a rotating storm called a supercell. And then you need equally strong high pressure downdraft, which is going to bring that supercell to the ground. And then that's going to cause your tornado once that supercell hits the ground. Now I just said a lot. This should all make sense in a second. So this really happens particularly in what we call a tornado alley. Okay, this is northern Texas, the majority of Oklahoma, okay, a lot of Kansas, almost the entirety of Nebraska, some of South Dakota. Now, tornadoes happen in Colorado and New Mexico and Missouri, Illinois, Arkansas, Louisiana, but they're really bad here. And that's because this particular region known as Tornado Alley has the perfect conditions for this tornado to form because it's got real warm, moist air coming from the Caribbean, and it's got really cold continental air coming from Canada. Okay, so right here, this is where you're going to see the bulk of the devastation that comes from tornadoes. Now, most tornadoes don't do a lot of damage. Okay, they touch ground and they're only alive for a little bit of time and then they burn out. But sometimes tornadoes can hang around for a long time and the wind speeds are enormous and they can pick up cars and trucks and destroy houses entirely. Okay, so we're gonna walk through the whole system, tornado from start to finish. Okay, so like I said, you need these characteristics for a tornado to form, to touch ground. So first you need something called wind shear. Okay, so let's assume that you guys are on the ground, you're sitting on a prairie in Nebraska. Okay. Okay. Okay, so first you need that characteristic wind shear. Okay, so that means you have winds coming on the ground in one direction and then you have winds high in the atmosphere or high in the troposphere coming in a conflicting direction. Okay, now when you have that, it's going to cause something called wind shear. So that's when you have this kind of cylindrical wind phenomenon happening high in the troposphere. Okay, now that in combination with strong rising warm moist air, I mean, we know this. Okay, rising warm moist air it's just your typical condensation, and that's going to cause very large cumulonimbus clouds. Okay. So those cumulonimbus clouds are those really, really strong, powerful thunderstorms that are very big, dark, but also very tall. That's what's really characteristic about the cumulonimbus cloud. Okay. So tornadoes almost always happen in the midst of a thunderstorm. Okay? So when you got that cumulonimbus cloud on top of that wind shear, you're going to have kind of a weird weather phenomenon going on. So you're going to have this kind of rotating wind pattern That's going to happen because of that wind shear. Those conflicting ground and high troposphere winds are going to be conflicting, so they're going to cause this kind of cylindrical cyclone high in the troposphere. Now, what's going to happen now, compounded with that really fast moving, so all the conditions have to be perfect, compounded with that really fast moving updraft, that fast occurring condensation, you're going to have, it's going to come into contact with that cylindrical wind shear. All right, now when that happens, it's actually going to bend, it's going to push this cylindrical wind shear up. And when you got that, now that wind shear that was originally horizontal is now going to be bent. Okay, so both sides of this are going to get bent, and it's going to be inclined towards the ground. So now you have this what used to be horizontal cylindrical pattern is now being bent downwards because of rapidly condensing upward wind draft going upward. Okay, now so now you have the continuous updraft, but if you have, so this is called a supercell. Okay, right now we're at something called the supercell. So let's go down our checklist. So we have strong updraft, okay, we have a humid ground, we have wind shear, and now we have a supercell. So now we have this rotating storm in the sky, which is vertical to the ground. It's no longer horizontal. Now if you have a strong enough downdraft from high pressure air, so this is your cold air, downdraft. If you have strong enough downdraft, it's actually going to bring that supercell, that vertical cylindrical storm high in the sky. It's going to bring this rotating thunderstorm down to the ground. And if it ever touches the ground, right when it hits the ground, that's when you're in trouble. So now you have this supercell in the sky compounded with strong downdraft. You got your strong updraft. Right when that strong downdraft balances out the strong updraft, now you have this really fast moving rotating thunderstorm that's actually about to come into contact with the ground. And if the downdraft is strong enough, that's when you got your tornado. Okay, so now you have this is really like a supercell that touched the ground. And once that supercell touches the ground, I mean, it's a wrap. Okay, so these tornadoes can range in intensity and severity, but if you got a bad thunderstorm, if you have a really bad tornado, typically in one of these regions, okay, this can really devastate communities and cause loss of life and serious property damage. Now, hundreds of tornadoes happen here, but very few of them have these really, really high intensity winds, but when they do, it's a natural disaster. They can be absolutely cataclysmic. Okay, it's tornadoes, guys. Thanks.